Welcome back. So in today's video, we are at AST Suspension in the Netherlands. We've got Coen from AST Suspension here with us. This is the first time I've been to this factory in the Netherlands. I'm really excited for Coen to show us around. So Ast-Moton is a brand that we've been working with all the way since sort of like 2007. We initially installed it on a Golf GTI Cup car. And me and Coen, we've known each other for probably about
10 years.
10 years or so now. Yeah, exactly.
Yep. And Ast-Moton has been around for over 25 years. We're actually celebrating our anniversary this year for 25 years. So we've been around for a long time, and we've known each other for a long time as well. So maybe we can go inside and I'll show you the whole process.
Yeah, so I think you want to show us all the way through from measuring up a kit all the way through to production, assembly, every single piece of the process.
Yeah, show you the factory, show everything, the assembly, development, everything from A to Z.
Cool, let's go inside.
Okay.
Okay, so we've got the M2 up on the ramp, and Coen's going to run us through what Ast-Moton do when they receive a car in which they don't already have a suspension system already developed for.
Correct, yeah. So what we do, we bring in the car, and we prefer it to be stock, like stock dampers, stock wheels, everything stock, so we can measure from the original car. So we bring it up the ramp, and then we first measure the droop.
So for people that don't know what droop is already, what is droop?
The droop is actually the open length of the damper. So as you can see here, it has a specific dimension from the center of the wheel to the wheel arch, to the edge. That's the droop of the full damper. You want to determine this on the car to make sure if the car is in full droop, if you're on a bumpy racetrack or on a bumpy road, that your wheels do not angle in or have a weird position or positive camber or toe in or toe out.
So by controlling the droop, what you're controlling is at the extreme lengths of the suspension travel, the negative toe gain and positive and all that kind of stuff. So you really dial in the hands of the vehicle and not let it get too out of control.
Correct. Well, this car is actually set up for the Nürburgring. Nürburgring has a lot of like elevations. So what you don't want is if you're in full droop on a racetrack, then the car gets really itchy or twitchy if you're coming down. So that's what you're restricting with this.
Makes sense. Perfect. And then what other aspects are you looking for?
Well, obviously the minimum length of the damper is very important as well. So what we do, we take the wheel off, we take the spring off the original damper, and then build everything back without the spring, put the original wheel back on, and then compress it fully into the wheel arch up until the length that it doesn't touch anything. If there's a little bit more room, we want to make the damper a little bit shorter. So we measure everything on the inside. So we know what the minimum length can be without the OEM wheel touching anything on the inside.
Perfect. So you're preventing it like touching any of the bodywork, any of the like inner arch, anything like that. So you'll never hear like any no sounds.
No scraping, because it's also dangerous. If you are fully compressed and you take out the wheel arch, it will be on the racetrack or on the street or whatever.
So we've covered two of the basic elements of designing a suspension system for one of these cars. And what other aspects do you usually look at as well?
Obviously, you need to know what kind of spring rates you want for the car. So we develop street car, we develop for full race car, and something in between. So what we do to determine the frequency of the car, we determine the motion ratio. Motion ratio is the relationship between the movement of the wheel and the movement of the damper. That's never 1-to-1 or almost never 1-to-1. With that information, you can calculate the frequency of the car, and then you can determine what kind of spring rates you want. So a lower frequency is for a street car, so it's like more comfortable driving. And then for a full race car with aero, full cage, and full slicks, for example, you want to have like a higher frequency.
Perfect. So you've taken all the guesswork out of the suspension.
We don't guess. No. We measure, calculate, and then that's why we have a couple engineers here that do all the work, all the calculations, and then we make sure that it's like spot on.
Perfect. And then you have obviously multiple spring rates anyway. So if someone wants to change the spring rates, they want to change sort of like the frequency of the car, they can do that if they want to.
Yeah, we have some race teams that actually give us like a frequency, and then with all this information, we can work towards that frequency. We can say, okay, this is the spring rates that you need in the front, this is what you need in the rear. The frequencies are never the same from the rear. So that's what we determine with this information.
Perfect. So we know how you develop a kit now. So let's head upstairs and let's see how they're designed. Okay, so we've got upstairs. We're now in the engineering office, and Coen is going to show us the kit that we were just talking about downstairs on the M2.
Obviously, it's been developed already, but we're going to show you some drawings here, how we do everything here. This is Rick. He opened up the drawing already for the Moton one-way. So every part, every small piece of the damper is in our SolidWorks drawing system. So it's never a surprise. We never have parts that don't match, don't fit. So after we've taken all the dimensions from the strut, we put everything in SolidWorks. So Rick has made a full design of the struts, of the shaft, of the top mount, everything made into one damper. So we know it 100% fits on the car. All the parts that are inside the damper and outside the damper are made downstairs in the factory. So we have control of all the quality of everything, but also control of changes. And that's why this, for example, is lying here. It's a drop link bracket that we used for over 20 years. But we now see that people are putting like wider wheels on cars and we need a little bit more space. So we redesigned this, made it a little bit more slimmer, calculated the strength, and we could have made this a little bit smaller so people have a little bit more space for the wheels, as you can see. Okay, so that's being said, let's go downstairs and check out the machine factory where we machine all the bits.
Okay, so we're down in the factory floor and we're starting off just by where all the raw product comes in. So Coen, can you tell us a little bit about what we're surrounded by here?
For sure, yeah. So this is actually the space where all the raw materials come in from that door. Here we are standing next to all the tubing and the tubes that we use for AST and the Moton struts. So you see some raw material here. This is solid material that we use for bushings, eyelets, all that stuff. And behind you are all the tubes that we use for the Moton struts, for aluminum struts, and also for the AST outer cases.
Oh, perfect. So you have aluminium damper struts as well as steel struts as well. So you have two different types.
Yeah, correct.
Perfect. So obviously this is starting off as like 10-meter long.
Yeah, these are very long pieces. So I think we have a couple mile of everything in stock. Once we know what we need, it goes up to the cutting machine. They cut it into pieces and they bring it into the factory to machine it. Obviously they need to be machined on the inside, they need to be machined on the outside, then the honing process, and then everything starts actually.
Perfect. So should we go through the facility and run through some of those processes?
So as you can see here, when we machine the outside of the strut, we put the thread on, which is a special thread only made for AST and Moton, and we make sure that it actually fits the car. So this is designed upstairs, where we just saw the video that Rick was designing. This is designed upstairs and we produce it downstairs with all the drawings here. After this, we're going to machine the inside, make sure that the smoothness is correct, and we weld the last bits to it. Looking at the thread, thread is a trapezium thread. And after that, it's differently machined than any other thread. The reason for it is that it's not sharp. You don't want it to be sharp. Either it will cut your hand, but it also cuts the aluminum after anodization. So what happens with this, it will never seize the platforms to the strut, which is great, especially if you're in a rainy or in a salty environment. After that, it's KTL treating, and then we can go ahead with the strut and assemble it. So with the machining of spring spacers, for example, like we have right here, we need to machine both sides of the product. So as you can see here, it's machined on one side, they take it out of the machine, and after that, they put it back in and machine the other side. What will result in this product? So this product is machined on both ends. As you can see the difference here? It'll start off like this, and now it's like this. So after this is done with the machining, it goes to anodizing to get the color that we need.
Okay, so Coen, you are holding a piston rod, so you can tell us a little bit more about the Ast-Moton piston rods.
Yes, of course. So it comes in, like you saw, as a raw material. Then we cut it in the right thread length, and then we machine the inside of the shaft as well. After that, it goes to chroming, and once it comes back from chroming, we machine the end Either it's for an eye or for an OEM top mount or for our own top mounts. The chroming process is done in Belgium. It's so strong that you don't need a DLC coating. It's strong enough. So in some cases people want to have a DLC coating. It's fine, you can have it. We also offer it, but you don't need it. Especially with this chroming, it's so strong and sturdy that we never see issues with this chrome issue.
Perfect. So for people who aren't familiar with a piston rod, so just to give them a bit of an orientation. So this would be obviously where the top mount would go. So we would usually see like the top mount nut or an eyelet. And then on the reverse side is where you would put the piston.
The piston, the shim stack, the adjustment goes here. You can see the holes that we need to drill in the machine as well. That's for the oil flow. So also the inside needs to be a specific roughness to make sure that the oil flow is also very smooth. The adjustment goes from here. So the knob, the rebound knob sits on the top of here. And like you said, either our top mount, OEM top mount, or an eyelet. So this machine is a brand new machine that we just got in. It's a machine that can 100% produce by himself. As long as we load it with material and we load it with programs, it can machine 100% by himself. It has a self-loading robot and it can take the material out of the machine, in the machine, and it does everything by himself. It can run 24/7, which is amazing to us because we can also do short runs of 10 top mount plates or 20 eyelets or like smaller quantities, but also big quantities. Like the top mount plates, for example, for the G80, which is a big success, this machine produces all that, the bearing carrier and the plate itself. So this machine is actually a pretty new machine to us as well. So what we use this machine for is for pistons, but also for eyelets, for example. This is an eyelet from Moton. This machine produces on both ends. So the material comes out, machines on this side, then this tool becomes a clamp, takes it there, this clamp becomes a tool, and it machines the other side. It saves a lot of time, saves a lot of money, and it still brings out the perfect product. So this machine is very important to us, not just to make the eyelets, but also our pistons. Our piston is something special. The machine runs about 17 minutes per piston to make it absolutely perfect. No burrs and 100% smoothness inside the holes that you need. It's machined from both ends. So it comes out of the material just like the eye, machined on one side, then it's flipped to the other side of the machine, and then machined as well. So this is just an example of a piston that we made. This is a 40 millimeter piston for our AST. Well, we obviously have a DDP piston, we have pistons for Moton, multiple, I think we have like 8 different pistons for Moton. I think we have 7 or 8 different pistons for AST. So it's all made for a different damping curve, for a different characteristic of the damper itself. So once production is done, we take all the parts, even if it's an eyelet or a piston or anything that we produce in here, it goes into the measuring room, which is super important for fitment, but also for the quality control in the end.
Perfect.
So let's go to the measuring room. So obviously this is one of the 3 measuring rooms that we have here in the facility. It's all climatized, so it's a little bit chillier inside, and it's to make sure that all the qualities and all the measurements are always the same, because it's always the same temperature.
Yeah, because the different temperatures will make the material very slightly different.
Very slightly, but it will change. Yeah, so that's why we're climatized all the rooms.
It's quite chilly. It's like a fridge.
Yeah. So let's go.
So we've just shown you the 2 measuring tables. At AST, we were measuring one of the GAX top mount mounts. So that is measuring against the drawing. So to make sure the part's been machined correctly, obviously that's going to aid with the fitment. Quality is really important.
Yeah.
And then also you were talking about a couple other machines in the room that you use for measuring the roughness, was it?
Yeah. For example, the machine behind you, this is a tool that we use to measure the roughness on the inside of the damper, but also the inside of the shaft and the outside of the shaft. So we measure the roughness because it's important for the way how the damper functions. So how smoother it is, the more or the less friction you have in the damper. So it performs a lot better.
Awesome, it's great to see. So let's head on to the next bit. Okay, so we're in one of the welding rooms at Ast-Moton, and Coen, what are you holding right there?
Yeah, I'm holding the rear damper of a Mitsubishi Evo 789. I was just picked it up to show you the welding. So we really take care of our welding. We want to make sure it looks good, but it also closes off the damper correctly. So that's why we have here the hose connector.
Yep.
And we put a seal in here, and then we pressure test everything before it goes off to KTL treatment.
Perfect.
KTL treatment is a treatment. It's like a base coat, and it's super thin, but it's very sturdy, very strong against weather. So salt, snow, rain, whatever, all the weather influences is very strong to keep it from rusting. So the KTL is thin enough not to interfere with the spring perch, so you can still like turn the spring perch very easily. This thread, like I said before, is like a custom thread only to us. And after KTL treatment, it's honed again to make sure that everything is clean on the inside and it's smooth, like we spoke about it before.
Perfect. Yeah, so it's welded, pressure tested, sent off for KTL treatment, and then it's checked again for the
Smoothness on the inside.
Yeah.
So honing, and then after the product is done, back from KTLing, back from honing, and goes upstairs for assembling.
Perfect. So so once we've done this, we'll head upstairs and then assemble some dampers.
Yep.
Okay, so we've finished up in the machine shop. So once all the parts are finished, they come upstairs into the stock room, then into the assembly area. So before we go through to the assembly area, let's talk about what's inside this room. And this is the first thing that I've picked up here, which is a nice tray of the anodized pistons.
Yeah, correct. So this room is full of parts. Everything that's done comes back from anodizing or back from KTL treating or back from honing. They are brought upstairs where we put them on stock. But before we put them on stock, we measure everything again to make sure that everything is in spec before the guys build this, the parts to build the damper. So a little further down, we have some springs, and you already found the springs. We offer 51 ID springs over this, and on this side we have the 61 ID springs. We use different inside diameters because on some cars you cannot use the 61 ID in the back, and therefore we have the 51 ID springs.
Yep, so this is all about optimizing the spring rate for the type of use that the customer has. So a customer might come to you and say, no, I don't want this spring rate, I want to go a little bit stiffer, I might want to go a little bit softer. And then also what you do as part of the damper building service is you change the damping curve as well.
If needed.
So that, if needed, to match the change of spring rate, if it is obviously a big enough change.
This comes also down to what we spoke about before as well with the motion ratio and frequency of the car. We determine what spring rate a customer needs. So in this case, we have plenty of different spring rates that we can use for that customer.
And any other special features of these springs?
They're made of high tensile chrome silicon.
Yep.
They're pre-blocked, so that means after you set up your car, you did the alignment, you weigh them, and then you start racing, it will never change height. It will never be different.
So if you're familiar with like fitting lowering springs to your car, sometimes there's like some settling. And that's what these springs all have eliminated from them. There will be no settling, come pre-blocked.
So what sometimes happens if you have a different supplier of springs that doesn't do that, then if you align your car and then the first round out the track, you hit the curb on your right front, then all of a sudden your right front is lower than your left. And that's something you don't have with our springs.
Okay, so we've just walked past the springs and then we've come to these housings. So these are the damper housings, and we shot them earlier on. They were obviously in a completely different color, so they're looking a little bit different now. So can you tell us a little bit about...
So they're now finishing the KTL treatment that I spoke a little bit before earlier as well. What you can see here is that the welding is done also on the inside of the lips. We really take care of our product. We want to make sure that everybody can have a product for years and years and years. So we make them very strong. The production is really keen on longevity of the damper. It's welded all around to make sure that there's no deformation inside the damper.
So we've just gone to the next line and we found some top mounts. So we've got all kinds of different top mounts for loads of different makes and models. So we've got sort of like a more straightforward top mount for the F chassis.
This is after
BMW. So this is your AST 5100 competition that has like the front top mounts, and then also the 2-ways, 3-ways, and then the Moton kits as well. So what's so special about these top mounts?
Well, the material is made out of 7075 aluminum. and they go up to a very high grade of camber. So you can go up to 4.4 degrees camber.
Wow.
Which is in most cases more than enough. Yeah, and it's just plug and play. So we have different versions for M2, pre-LCI, LCI, 3-bolt, 5-bolt, competition. So we have all different versions, and just to make sure everything is plug and play.
Awesome. And then this one's quite a special one as well. It looks relatively simple, probably from behind the camera, but this is from a G-body safari car, isn't it?
Yeah.
So this has got some like angled threads in there.
Yeah,
you were saying. Also quite expensive to machine as well, because it's not flat. It's a different size the whole way throughout.
Yeah, this is one of the most expensive top mounts that we produce. A lot of competitors, they reuse the OEM one, they coat it and that's it. But we make a full aluminum version of it, and it's also camber adjustable.
Yeah, so you've got some offset mounting points here as well. So really nice.
Very cool.
Nice piece there.
And then obviously if you have a car with a double wishbone, you don't need to adjust camber on the plates. You can adjust camber on the arms. We have a normal non-adjustable top mount. Still comes with our bearing in here, and it's just plug and play on the damper. Yeah, well, this is the chrome cylinder. This actually one is DLC coated.
Yep.
Like I said before, some really need it. Some customers want it, especially if they're in a super rough area. But our chrome work is super strong, so you don't really need this. It's nice black. It looks amazing. But then if you look at our chrome version of it, just as nice. It's friction welded.
Yep.
And this is for 2-way and 3-way. So the hose comes out of the top.
Perfect. So you're stocking literally hundreds, if not thousands of these as well. So you can turn around quite quickly.
So here you can find a lot of universal parts. So parts like that we use for Moton, we use it for AST, we use it for industrial dampers. So it's more our universal parts. Also the hoses, obviously we buy our hoses from Goodrich, and we use them for AST and for Moton. So it's not that like, oh, maybe Moton is a little bit more expensive. We use better materials, or we use better brands for Moton. No, we use the same materials for AST.
Yeah, there's certain things that are universal that there's no performance or cost benefit in changing the specification or anything like that. But there are differences between the Moton and the AST dampers, which we'll run into in a second when we go into the build room.
Go to the assembly room.
Okay, so we have an AST suspension kit out here in front of us. Koen's here to walk us through the differences between like an AST 5100, 5200, 5300, and then a little bit of the differences or the advantages of like the AST kits versus the other kits on the market. So we've run us through it.
Well, obviously this is a 5100 competition is how we call it. It comes with top mounts, front and rear. In this case, it doesn't need a top mount in the rear, but the competition normally comes with top mount, front and rear. AST is always an inverted system, except for double wishbone cars. They're all being called 5100s, and the inverted system is the majority of them is in the front only. We have a couple options for the rear, but most case the front is inverted, and the rear not.
So what's the reason for these being inverted versus non-inverted?
Well, the inverted system is very strong in side loading. So if you're into sprint racing or autocross or like short track racing, then the inverted system is very strong in side loading. So it's like a double tube inside each other. That's why they're very sturdy.
So in like a McPherson setup, you have like a bending load going through the damper. And obviously we know that deflection is obviously an enemy in any sort of like handling context. So what you're resisting is the bending of the damper. So it doesn't deflect. You've got all the geometry that you wanted more of the time. So that's a big benefit. So it's a lot stiffer, isn't it, as well?
So in a lot of cases when you're in full drop with a non-inverted damper, you can have play between the shaft and the sharp body. With this, there's zero play. It would never happen.
Okay, so in other damper designs, when it goes into full droop, it's obviously fully unsupported. So I guess that means that when it might get like a shock load all of a sudden, it could bend because
it could either bend or harm the inside of the tube. Or even worse, it could the seals. It could wear out the seal as well. Because it's like not 100% straight, and then it will hurt the seal on one side, and then it will start leaking.
Okay. So then with these 5100s, obviously they're non-remote reservoir. When you step up to a 5200 and a 5300, you go remote reservoir.
Correct.
So with the 51s, you've got the adjustment on the front if it's inverted on the bottom.
Yeah,
so
rebound adjustment.
So this is the rebound adjustment on this.
Yeah.
And then when you go to the external reservoir on the 52s to 53s, so you have a takeoff on the top, which then has your canister, which has the compression high and low speed adjustment on there.
Yeah.
So what is compression and what is rebound?
So the rebound is the controlling of the extension of the shock. So the spring is trying to push it in full droop to full extent, and your rebound knob holds it from going too quickly or too slowly. That's what you...
So if you stiffen up the rebound, you're slowing down that, and then if you soften it or open it up, and you're literally...
Controlling the spring.
Controlling the spring, yeah. So there's a needle valve inside here, and you're opening it up or you're closing it up. So it sounds complicated, but it's super simple.
Yeah. And then on the compression side, you just control the movement of making the damper shorter. So if you hit a bump or you hit a curb, the damper goes into compression, and the speed of the compression is something you regulate with the high speed or the low speed knob, or both.
And then all of these bits and pieces we spoke about earlier, for example, you've got the shock body here, you've got the roll bar clamp on here, you've got all the spring perches, the spring isolator, you've obviously got the shaft in there, the cylinder, the top mount, all these components obviously all come together to see what we see out here in front of us.
Yes.
And also we spoke a lot about these dampers being sort of like made to order for customers to a certain extent. So what have we got going on here with the piston and the shims?
So none of our dampers are on stock. So we build everything to spec of the customer. So if the customer asks us like, hey, I want to do a track day, then his setup would be like this. If the same customer says, I have another car and I only drive it on the road, it might look the same, but it will feel 100% different. And it doesn't only feel different because of different spring rates, but it also feels different because of the settings on the piston. So you have a piston here with shims on the compression side and on the rebound side, and that makes how the damper feels. And that always need to correspond with the springs. That's why a lot of people ask us like, hey, I want to change spring rates. Do I need to change the valving? Well, with our dampers, the adjustment range is so big that you don't have to revalve constantly all the time. You could just between like 20 to 30% up or down and use those springs.
And you would adjust like the shim stack, or you might choose a different piston to get certain types of sort of like damper curves and things like that.
If a race team or just a normal customer asks us like, hey, I want to have this graph, I want those in my 2-ways or 3-way damper, then we can set it up on the dyno.
So once it's come back off the damper dyno, what happens then?
Then everything goes back on the workbench. The first engineer who actually built it obviously checked it on the dyno, checked the dimensions and everything. Then he asked for a fellow engineer to come here and then redo everything. Not the dyno, but measure everything, make sure the spring rates are correct, make sure the lengths and everything is all right. And if that is correct, then he'll sign off the product certificate. The good thing with this product certificate is that it has a number on it. The number corresponds with the number that is on the shock as well. So if a customer has an accident and he needs one right front damper, he doesn't have to send us the left front as well. He can just give us the number and we can 100% replicate what he had before. But also, if he ever serviced the dampers before, there's like a file in our computer. We can exactly see when it was rebuilt, by who it was rebuilt, what material was used, which batches were used, etc., etc. So everything is traceable from A to Z.
Okay, so we've got a set of Moton one-ways out here in front of us. I'm just going to run through the differences between the Motons, other dampers on the market, and obviously the specifics of this kit here we've got.
Well, same as all the dampers that we make here in-house, it's custom made, so there's nothing off the shelf. It's really made for the customer's purpose. So with most customers, we have a discussion about what they want to achieve with the car. In this case, the customer wanted to have like a sort of lift kit for the nose. So we made the damper so they can accommodate that. This, in fact, is a Moton one-way. It's for the G80. It's non-coilover in the rear. The front comes with top mounts. The rear also comes with top mounts. It's 22 millimeter shaft in the front and a 14 millimeter in the rear because there's not a lot of space in the rear as well. Camber adjustable, like I said,
So camber adjustment, if you do need camber adjustment, starts off with the rebound adjustment on the top.
Yes.
And then you can upgrade to 2-way or 3-way with the remote reservoirs. Yeah. So there's just like a little takeoff at the bottom there for the remote reservoir.
Yeah, you can see here, it's a connector. You can put a reservoir on there. So you can grow into your kit. You can start off with a 1-way and think, hey, I'm getting better and better. I need a 2-way or a 3-way. And you can slowly upgrade into your damper.
Yep.
This actually is very good in endurance racing. So we sell a lot of Moton for Le Mans, Pikes Peak, 25-hour races, 24-hour races, because it's a very stable system.
So one of the reasons why is because there's not really any friction in the system, or there's very low friction. Yeah. And part of the reason for that is that it's non-inverted.
Yeah.
So you were showing me this earlier, and obviously one of the risks with running like a non-inverted system is obviously on the McPherson cars where they're not really particularly resistant to side loading. So how do you prevent that, or what is your solution to the side loading?
Well, in this case, you're holding the shaft right now, and it has a lot of support built into the damper. So we have this longer support piston, which is part of the top guide, which means that even if it's on full droop, which means like this, it still has a lot of contact points inside the damper. So you would never have issues with side loading or whatsoever.
And this is what tends to like bend pistons or accelerate wear on components.
Yeah. And it's just this is with oil with O-rings. This is with Teflon strips. So it just keeps on moving throughout the damper without issues, without stress, without hurting the inside of the strut as well.
Okay.
So what you see sometimes, if you don't have this system, it might wear on the inside of your strut, meaning that if you open up the damper, you can see wear on the inside.
And these are obviously precision machine components. So obviously, if you start to get wear, then it's not going to behave the same as when you first start to run the kit and you're chasing around the setup. Why has this thing changed? And it's down to wear of the components. And also on this particular system as well, you've got like orifice adjustment.
Yes.
So
different than the ASD.
Yeah, different than other sort of like makes on the market. So you've got this like nut where you basically twist the shaft and it just
opens up some holes.
Yeah.
So there's like a plate covering the holes, and as soon as you open it up, it opens up some holes. So the Moton 1-way, 2-way, 3-ways, and 4-ways, we test them on the dynos, and that's where we have always the graph with the 2-ways, 3-ways, and the 4-ways. You get a complete dyno graph of your damper, and we'll show you on the dyno as well.
Yep, let's go see that out. And once the kit's come back from the dyno, it's been signed off, it then gets signed off by a couple of engineers, cross-checked, and then it's ready to be delivered to the customer.
Correct. Then they go in another area where they're being packaged. First, they're going to be photographed, so we know exactly what left, but also to update our websites and everything, that everybody can actually see the product, what they're getting.
So thank you so much for explaining all about the Moton suspension. Obviously, if you've got any questions that we haven't answered, then definitely reach out to us. Be happy to help. Thank you for watching this video. If you haven't done already, then give us a thumbs up. If you want to watch some of our other videos that YouTube thinks you'll like, then click up here. If you want to watch some other videos in the same playlist, then click here. And if you haven't done already, then hit the subscribe button right here.